Okay, we'll do 7E. Okay, sketching using quadratic formula. Just go back a little bit. Sketching by completing square. It can be useful for like every time, like all the graph or all the functions can be sketched by this method. Okay, it's a very useful method. You can deal with all the quadratic equations. If you want to sketch by using turning point form, fine, because you can always get that. Back to what we have for the factorized one. This one only works in some of the graphs. Okay, what kind of graphs? Well, at least needs to have x-intercept. Okay, if you don't have x-intercept, you know there are graphs that have no x-intercept. If you don't have x-intercept, can't factorize. Okay, there's no way to factorize. Or also you need discriminant greater than 0. Okay, discriminant needs to be greater than 0. That's how you can factorize it. If you can't have discriminant greater than 0, no way to factorize. So therefore, this is not a really great method to do things. Unless you can really see, okay, this one can easily be factorized. Okay, 12, I want to make it 8. I can easily do that. So then I factorize. Otherwise, I will recommend the completing square method. Okay, I will recommend the completing square method. So today we're going to learn another method. It's using the quadratic formula. See what we learned for chapter 5. We learn factorize, we learn completing square, and we learn solving by quadratic formula. It's coming back, like all of them coming back, and we're trying to use those knowledge to sketch. Okay, to sketch. Okay, this is not a good method. Okay, this is not a good method. I don't really like this method. This one, again, like, think about the factorized form. Factorize is like when the numbers are like they're integer numbers, and I can easily factorize, and I use the factorized form. Well, if you can look at this one, well, look at B. A 2 and a 3 almost can't make a 4, right? Think about that. I want a 1, 2, and 1 and 3. Can't make a 4, really. Like either it's a 6 or 2 and 3. So I can't make a 4. So I can't easily use cross multiplication to factorize it. Like it's very, very hard to factorize it. Therefore, but we still don't want to do completing square. Okay, the thing is I don't want to do completing square. I want to find x-intercept first. Okay, I want to find x-intercept first. So if I just want to find the x-intercept of this function, what we can do is we make when y equals to 0. Well, because I don't know how to factorize, I can't factorize it. If I don't complete square, I don't know how to factorize it. I still want to solve out the x-intercept. I just need to make y equals to 0. So what I have is this. Okay, that's what we have. So what I know is a equals to -2, b equals to -4, and c equals to 3. Okay, check. What's discriminant for this question? What's discriminant in general? B squared minus 4ac. So it's -4 squared minus 4 times a times c. Okay, b squared minus 4ac. What do I have here is 16 plus a what? 24. That gives me a 40. Can I solve it? How many solutions do you have? Do you think those two solutions will be rational solutions or irrational solutions? Irrational, because square root 40 is not a square number. Like I can't get out of the square root this 40. So it will be irrational. Okay, it will be irrational. It's not a rational number. If you have a 16 here, then it will be a rational. You don't have the square root. So you can decide you have rational solutions or irrational solutions. by looking at the discriminant. If your discriminant is square number, like 1, 4, 9, 16, 25, those numbers, you will have rational solutions. If you have like 40, can't take the square root, you have irrational solutions. Okay? So what we will have is x will equals to what? X equals to minus b plus minus square root of discriminant over 2a. Okay, minus b plus minus square root b squared minus 4ac over 2a, but the b squared over 4ac have worked out that. That's the discriminant. So I just put like this. So x equals to minus b is a 4 plus minus square root 40 over 2 times what's a? Minus 2. What's square root 40? 2 root 10, right? 2 root 10, 4 times 10, 2 root 10. Okay, so what I have here is, okay, 4 plus minus 2 root 10 over minus 4. I can further simplify that, like separately divide them. 4 divided by minus 4, I get a minus 1. Okay, and then plus minus 2 root 10 divided by 4 is a root 10 over 2. Okay, it's a root 10 over 2. Okay, the 4 divided by the minus 4 and the plus minus 2 root 10 divided by the minus 4, like separate them. And what you have is minus 1 plus minus root 10 over 2. Well, 4 over minus 4. And the plus minus, well, the plus minus, you meet the negative, the plus becomes minus, minus becomes plus, but it's still a plus minus. So you can say that's over 4. So you have a minus 1 plus minus root 10 over 2. Do you get that? I want to make it into this form because I need to see where's the middle later. Like this form will be easier for me to see where's the middle. But like anyway, we have x-intercept here. What's root 10 approximately? 3 a bit. Can't be 4, okay, 3 a bit. So 3 a bit. So minus 1 plus, well, let's just see it's 3. Like plus 3 a bit over 2. Okay, 3 point something over 2. So it's minus 1 plus 1.5 and a bit. So what's approximately the value will be? Approximately 0.5, about 0.5, okay, about half. So, well, it's approximately here. Okay, that's minus 1 plus root 10 over 2, comma 0. So if it's minus 1 minus 3 over 2, 3 a bit over 2, what that will be? What's the minus 1? Minus 2.5. Great. Minus 2.5. 1, 2 a bit. That's about here. So it's minus 1 minus root 10 over 2, comma 0. Okay, I have worked out the x-intercept. Well, even though it's not a good number, like I still work out that. Okay, next thing is, where's the y-intercept? Y-intercept? 3. 0, 3. So here. Okay. 0, 3 here. When you know the 2x intercept, can you find out the middle? Where's the middle? Okay, so what's the actual value? It'll be a really nice value. Look at the two number. Minus 1 minus root 10 over 2. Minus 1 plus root 10 over 2. So where's the middle? Minus 1. So if from minus 1 go to the right this much, go to the left this much, so it will be the middle. -1 will be the middle. So I can see the middle quite easily. So the turning point must be here. Okay, so it's symmetrical about this line. It's symmetrical about -1. Well, therefore, I have another point here, like -2, 3 as well. Now to find the turning point. Okay, so again, the question back to the original step as what we learned last lesson. So we make when x equals to -1, y equals to -2 plus 4 plus 3, y equals to 5. So turning point is -1, 5. Okay, sub -1 in, and you work out the y value. That will gives you the turning point. Turning point is -1 and 5. Okay, turning point is -1, 5. So the point is here. -1, 5. And therefore, it's easy to sketch the graph now. Well, it's a downward shape, and you can see that it's a -a. It's a downward shape. But this method only works if your discriminant is greater than 0. If it's less than 0, I can't find out x-intercept, which means there's no x-intercept. And I need to use completing square to do it. Okay, I need to use completing square to do it. Well, why I choose B to start? Because if we think about A, okay, if we're trying to do this method using like the quadratic formula to solve out x-intercept first, well, first of all, a 3 and a 5 is not going to give you a 6. Think about that. A 5 and a 3 can't give you 6, right? So what you will do is you make 0 equals to 3x squared minus 6x plus 5. We check about the discriminant. Discriminant is minus 6 squared minus 4 times 3 times 5. And that's 36 minus 16. What happened? It's less than 0, and there's no x-intercept. Well, I can see from that no x-intercept. Well, if there's no x-intercept, what that means? That can't using this method, and I must go for complete square. So therefore, must do completing square. Okay, I just show you a counter example in this exercise. It's not working like for some of the equations.
Why do we use this? Why?
Well, if you're not good at completing square, there's another way can still help you. Like it just depends on which way you think is quicker to do things. Because you can see if I really get familiar with the quadratic formula and I work out x-intercept, I can very easily see where's my middle, and the sub back in is not going to take that long compared to completing square. Does that make sense? I get my x-intercept and directly get the x value of my turning point. It's not a bad method, it's just not useful for all the functions. Check discriminant. If discriminant is less than 0, you must use completing square. It's also not working for the factorized form. This can't be factorized as well. Anything. Complete square will work for anything. Well, I'm not going to keep going for this one. Just another practice for you to do. Just finish that one. Anything before page 9 for today, and you can start to do the scheme of work on your textbook. Well, like use completing square to finish this one, and I can see whether you get it wrong or right, and you can work on your textbook questions. Any questions for this method? Well, you can try a couple of questions by using this method and see whether you like it or not.